We're going to start this lesson by reviewing some visual derivatives. So you are going to start by sketching a copy of these graphs into your notes, and then you're going to, on top of the graph, sketch the derivative. So we're going to review how to connect the derivative to the original graph. So what we see with this graph is we notice that the function is decreasing, 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 decreasing. It is flat, and then it starts increasing. So over here we have a negative derivative, and over here we have a positive derivative, and we need to put an x-intercept at the place where the slope is flat, because a flat slope is a slope of 0. So then we have our derivative is negative, 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 negative. It's 0, and then it's positive, positive, positive. Okay, so there is our derivative. So then here we have a flat part right here and right there. We see that the function is increasing, then decreasing, then increasing, increasing, decreasing, increasing. So we need a positive derivative to go with increasing, negative derivative to go with decreasing, and then positive derivative to go with the part where it is increasing again. So there are our visual derivatives. So this is a picture you drew back in Unit 4 that I'd like you to draw again, where we connect the function f to its derivative f prime by section. So we see that in this section we have a positive derivative which corresponds with an increasing function. We have this section, we have a negative derivative which corresponds with the decreasing function, and then positive again corresponding back to the increasing function. So you should pause if you need a second to get this picture fully sketched, but it's important to be able to understand how f prime and f relate to each other. And now we can review how to find maxima and minima of a curve using the derivative. So we see that we go from increasing to flat to decreasing, right? So the only way to draw something that is increasing and then flat and then decreasing is to draw a maximum, right? And then right here we have a part where it is decreasing and then it's flat and it's increasing. And the only way to do that is to have a minimum, right? We're decreasing, we're flat, we're increasing. So that creates a minimum. So maxes, that happens when f prime goes positive to negative, whereas a min happens when f prime goes negative to positive. Okay. So here's a graph of f prime, and it's slightly different than the ones we've looked at earlier in this lesson because it has a part where it bounces. So we can see then that, okay, we have a maximum right here because we're going from positive to negative. We have a minimum right there because f prime goes from negative to positive. But then what happens here is we have f prime is positive, and then it's 0, and then it is still positive, right? So how would we draw that? If we draw a function that is increasing and then it's flat and it keeps increasing, that makes what we informally call a shoulder. Okay, so that's when f prime bounces. Okay, when there's a bounce, that's going to create a shoulder in f of x. Shoulder in f of x. Okay. So just quick review on visual derivatives. Now I'm going to give you a graph. Make sure you read the label carefully and you answer the question about the graph. So you should do this by yourself first. So you should pause the video and then unpause to hear my explanation. So here's a graph of f. Identify all points on the curve where f prime x is equal to 0. Okay, so I'm going to look for every place where I have a flat slope. So right here f prime x is equal to 0, right there f prime x is equal to 0, and right there f prime x is equal to 0, because those are the places where the slope of the curve is flat, and this curve represents f. Identify all points on the curve where f prime x equals 0. Well, this is a graph of f prime, so what we should do then is just label its x-intercepts. Right there, f prime is equal to 0 because the output of f prime is 0, and then you should remember that that is a point where f, the curve that f prime is describing, is going to be flat. And if flat, and we'll talk about more specifics later as we keep going through practice problems. Okay, so here's a graph of f prime. Identify all points where f prime x is equal to 0. Okay, again, this is just f prime, so we're just looking for the x-intercepts. That's where the output of f prime is equal to 0. Those 3 points. Here's a graph of f prime. Identify the intervals where f prime x is positive and negative. Okay, so right here, f prime x is negative. Right there, f prime x is positive. Right there, still negative, so we can just kind of, use that. And then right here, positive, right? Again, so basically whenever the output's positive, obviously f prime's positive. This is a graph of f prime. So these are the intervals where f of x is increasing, and these are the intervals where f of x is decreasing. So now we're going to identify all x values where f of x is at a minimum. So what we're looking for is places where f prime is going positive to negative. So let's make a copy of this picture to work with. Okay, so we can see, we're looking for minimums. Okay, so we can see right here, f prime x is going negative to positive, so that's going to be a min of f. And then we also have right here, f prime x is going negative to positive, so that will be a min of f as well, because we're going from decreasing to increasing, and again, decreasing to increasing naturally causes a minimum. Okay, here's a graph of f. Identify the intervals where f prime x is positive and identify the intervals where f prime x is negative. So whenever f is increasing, f prime is positive. So right here, f prime is positive. And then in this section where f is decreasing, f prime is negative. Okay? We're going to describe f prime given this graph of f. Given this graph of f prime, we're going to describe f. So what do we know about f prime? It's positive, 0, and then stays positive. It bounces. So what is f going to look like then? F is going to increase. It's going to be flat, and then it's going to keep increasing. Remember that f prime just describes the slope of f. It doesn't actually say where f is vertically. So we could even have it like down here, as long as at that corresponding point where the bounce happens, that's where the shoulder happens. Or it could be up here, increasing, flat, increasing, right? So this derivative is only telling us the slope of the curve, but not exactly where the curve is on the coordinate plane. Okay, that's it for now. I'm going to continue in part 2.